This video explains the Ewart Smith theory for kinetics of emulsion polymerization. This theory takes into account three influencing factors that govern the rate of growth and size of the polymer particle. The three factors are rate of radical entry into the polymer particle, rate of radical exit from the polymer particle, and bimolecular termination of radicals. A quantity n is defined as average number of radicals per polymer particle. Three limiting cases for this n is identified. Case 1 is when n is very less than half. In this case, radical desorption from polymer particle into the aqueous phase will be significant, and this will lead to bimolecular termination of radicals in the aqueous phase. Due to this, chain propagation cannot happen to a great extent, and so the polymer particle size will be small. Case 2 is when n is approximately equal to half. In this case, when a radical enters the polymer particle, chain propagation will be facilitated. When the second radical enters the same polymer particle, bimolecular termination will happen within the polymer particle and the particle will become dormant. So this means that at any instant, only 50% of the particles will be active with chain propagation and 50% of the particles will be dormant. Radical desorption from the polymer particles is negligible in this case. Case 3 is when n is very greater than 0.5. The polymer particle will be very large in size so that more than one propagating chain is within the polymer particle, and desorption from the particle and bimolecular termination within the particle will be negligible.